Hey, hello, my name is Lindsay Franz. I am a systems librarian at the National Library of Medicine. And today we're going to talk about our migration of IndexCat from Fedora 3 to Fedora 6. I wanted to give a little background on what IndexCat is. IndexCat is the index catalog of the Library of the Surgeon General's Office, which is a multi-part printed bibliography. So it, in physical form, it listed all of the items in the Library of the Surgeon General's office, anything collected between 1880 to 1961. The Library of the Surgeon General's office later became the National Library of Medicine. And the material data from 1400 through 1950. It is not an index of all material published, but at the time in 1895, it was the largest medical library in the world, and today NLM is the largest medical library in the world. So we digitized it in 1999 when they were began the process, when they were awarded the contract for the digitization of the index catalog. It was awarded through Drexel University, and we had a 2-year digitization period. We did not use OCR to digitize it. Instead, it was done with triple manual keying with computer validation routines for standardized generalized markup language formatting. We couldn't use OCR due to the small type. The smallest size was 7 points. These citations had no line separations due to trying to bring down the cost of publicizing the index catalog. So they kept everything very little spaces and very little fonts. And there was also a lot of diacritical marks due to languages. There's dozens of languages. So it was a manual keying of more than 3.7 million citations throughout this 2-year period. The Quality Assurance Committee reviewed the first round, and there were significant errors. So additional training had to be done in order to meet the contract of a 99 out of 100 keyed characters. The QA committee, after doing some testing, figured out, and some programming updates, figured out that some batch quality edits could be done. And so this allowed for larger correction, like we could correct larger groups of citations by computer. This is also something we still do today, is batch updates. So quarterly, we update the IndexCat with whatever our updates are. At the time, we're doing shelving notes, but we make language updates all the time. So a final digitized copy of the index catalog was submitted in December 2001 in SGML format, and then it was converted into XML. And the data was subsequently ingested into our Fedora 3 repository in 2014. And just what IndexCat looks like today. I gave you a screenshot. I don't have time to go through and show you a search, but I encourage everybody to go and take a look. There are, as I said, 3.7 million items. It's a list of journals, monographs, books, pamphlets, newspaper articles, dissertations, journal titles. IndexCat reflects the same publishing pattern as the physical index catalog, so series, volumes, references, and the original dictionary arrangement is the same. We did add language, but it was based on publication location, so it's not always correct. So that's a project we're currently working on with batch updates, is correcting the languages to make sure they're correct. And as a digitized resource, this really does allow users to search all the descriptive information as direct search terms. It really makes it much easier to use, and it's a great resource. So I encourage everybody to go and check it out. And then now I want to pass this over to Calvin, who's going to talk about the actual migration process.
So sharing screen. Yep. Hi everyone. I'm Calvin. I'm software developer at the NML digital repository team. So thank you, Lindsay, for the interesting overview of the IndexCat. And I'll be spending the next part of the presentation just focusing on our migration effort, moving the IndexCat from Fedora 3 to Fedora 6. So out of our projects that are considered for the Fedora 6 upgrade, IndexCat we figured was the best candidate for Fedora 6 upgrade and get us into Fedora 6 since it has all the data are simple XML data and the object has no relationship between the items. And so therefore we figure it's the best way to migrate it first. So far the migration is still ongoing since we have 3 strings, dev, QA, and production to complete the migration in. So far the migration is ongoing and we have completed the full migration of the dev stage and currently reindexing the QA server stage. What I'll be discussing on is our migration process, the migrated OCFL, the reindexing, the migrated data validation, and finally some lesson learned and our next steps. So to prepare for the migration, we had to take some factors into consideration since we knew from our explorations with the Fedora 6, the migrated Fedora 6 OCFL data consumes the high volume of inodes in file systems. Since each object has the tuple structure, so it creates a lot of folders, and we had to request for a mount that's be able to hold all these OCFL files. So we have a NetApp mount drive that supports up to max files of 500 million inodes and 2 terabytes of space. For servers that we use are Oracle Linux 8 servers of 1 core and 8 gigabytes of RAM. And we deployed Fedora 6 with Tomcat 9, Java 11, and we use MySQL 8 as our database. We use the latest version of the migration utility, 6.3.1 to migrate our Fedora 3 items, which are stored as a CRUA data type from Fedora 3 and migrated as to Fedora 6 as archival groups. So I have listed here the basic command parameters that we use to basically migrate our data. You need to specify the Fedora 3 data stream object directory as well as the target directory for the migrated data to live. And also we had turned on the continue on air flag just so that the migration would still keep going even if it's running into hiccup during the migration. So for our 3.8 million IndexCat citations, it took about 5 days to complete. So some interesting findings with our experience with the migration tool. It's interesting to point out that since we have quarterly updates for this Fedora 3 objects, the object audit of the versioning are tracked in the migrated Fedora object, but only the latest binary are stored as OCFL, but it will list the versions of when it was updated. And we also, in our migration, we also have tested other capability of the migration util, such as the metrics function, which we deploy with Prometheus and Grafana in Docker. Together, they are useful in gathering data points about the migration process, such as the garbage collection rate, CPU usage, and the migration speed. So here I showed just a screenshot of what the dashboard looked like in Prometheus. Which is useful, I guess, in performance tuning of large sets of migration data in the process. We also tested the has-only option, which hoping to reduce the migration processing time by only, I guess, copying the top level of each data stream. but we find that it did not significantly reduce the processing time as we hope, so we left that alone. So here's just a slide about the OCFL structure that the migrated data will be in. I'm sure you're all familiar with the OCFL by now. So it stands for Oxford Common File Layout. And I have the community link there to check out. But the benefits of the OCFL is just allows creation of versions of digital objects, enabling track changes and manage different versions of content, fixity and audit, so it includes ensures the integrity of the digital object by just checking for corruption or losses. Durability, which it promotes long-time durability and accessibility of the digital objects by using the same file structure, naming convention, and metadata representation. Also interoperability, which to be compatible with various digital preservation tool system workflows, so it's easier to integrate into any existing infrastructure. And reproducibility, which creates the digital object in their component, ensuring the original content can be reconstructed even with absence of software or hardware. So here, let's go over a sample migrated IndexCat object. Hope everyone can see. So in Fedora 3, the data have 3 data streams, the Dublin core and the IC XML itself, and also the route XT. So in Fedora 6 OCFL, the Fedora resource ID are mapped directly to the object ID, which uses the SHA-512 and triple storage. So this creates a 3-layer folder structure here with the SHA-512. So you have to do a ID lookup when you're looking to the file system or to track specific IDs. But yeah, as you can see, the migrated items consist of all the mentioned data stream, and each of them has their own description, which are just the auditing trail files. So here's what our typical RelX and Dublin core file looks like for any individual IndexCat items. So RelXC just tells which volumes and series that one belongs to, and Dublin core just a basic metadata about the item. And here's the audit description file looks like in the migrated item. Okay, now I'm going to discuss our migration experience in AWS. So our motivation and purpose was to test and compare migration and validation speeds between on-prem server in migration versus the AWS EC2 higher CPU classes migration. For this, we put our data stream and object directory of Fedora 3 in EC2 through S3 and ran the migration on a C5 X large EC2 instance machine, which is 4-core CPU and 8 GB of RAM. And we compressed and retrieved the migrated data back from S3. And from our testing, we observed that compared to 5 days of migration processing on-prem, on AWS, it only took 18 hours for the 3.8 million records. Unzipped 40 gigabytes of data stream and object directory, migrated to 88.5 million files and folders. So it consumed quite a bit of inodes, as I mentioned before, and about half terabytes of worth of space. But this does confirm that it was much faster to migrate on AWS than on-prem for large sets of data. However, we did run into some challenges retrieving the migrated item back from S3, since we had to do it over the organizational VPN, and that file size just had some issues since we're not allowed to do it over direct connect. So that's something that we're working on, hopefully in the future to resolve. But right now, yeah, we're just migrating with our on-prem server at the time. So here's a quick screen share of what our migrated item in Fedora 6 dev Tomcat looked like. So as you can see, this item has the data stream from Fedora 3, and the created at stamp is when this item was first ingested into Fedora 3, and the last modified being when it was migrated to Fedora 6. And some typical information such as which volume pages from the properties. Here. So to load the migrated item in Fedora Tomcat 6, during the initial startup of Tomcat, the migrated data will have to be reindexed into MySQL database to build the search index in database. And in our migration processing, this took about 4 objects per second and totaled about 8 days to complete. And currently this process cannot be resumed and need to complete uninterrupted. And in our use case, we had to restart this process a few times due to the server maintenance and I guess some security scans that's taking a lot of CPU on the same server. So there are a couple properties that could be set to enhance the performance of this reindexing by enable the reindex multi-thread and set the reindexing fail on there to false in, I guess, our Tomcat environment. And before the migrated data can be loaded to Fedora 6, we ran the data through the migration validation tool as well for the migrated OCFLs. The validation tool is also a Java file, so you can give the parameters of your F3 data stream and object folders as well as the OCFL target directory, and it will compare the source object and the target object. And you can have the output of certain types like CSV, JSON, and HTML. And here are the validation results parameters. You will either have an OK status or a fail status of each of these. So the source object exists in target validates if the source object that exists in the target, and binary metadata validates the metadata associated with binary objects are the same between the last modified and the creation dates. Binary version counts, check the number of binary versions matched between the source and target repository. Binary size, see if the binary size matches between the source and target. Metadata properties that are validated, such as model state, label, owner ID create date and the last modified date, and also the binary head count if you're using I guess head only, or it matches the heads of the source target. So here's what the validated items look like in server. Again, this is also stored in the tuple storage, similar to OCFL. And this one is checking the source object exists in target, and this has status okay. So you get our output in default in JSON. So that's our results for that item. So some lesson learned from this process of migration Fedora 6. Firstly, it was very beneficial to work and get help from the Fedora developers on Slack and attend the weekly call just to issue out if there's troubleshooting issues and even asking for features. I think we requested for the rezone functionality in migration tool, since sometimes on server we run into some migration processing at sitting in the middle of the migration. So resuming function really helped that to ensure the migration complete successfully. And also, I think it's helpful that the larger repository need to anticipate the validation, migration, and the re-indexing runtimes and plan accordingly. And this probably have to do with either coordinating with your DevOps team or DBAs on make sure no server patching occurs, something that could knock the processes down, stuff like that. And also another thing, the lesson learned is, I guess, just familiar, know what to expect with the OCFL data and plan on how to reintegrate the OCFL with your existing tech stack. And I guess another lesson is just take some time to optimize the migration or the validation speed by adjusting the parameters that are in the tool itself. So yeah, the next steps that we have, finishing up the QA deployment and then move on to the production deployment. And also we are looking at the auditing tool from the Camel toolbox. We have deployed it in dev with Solar and Fuseki as our tools for doing that. And in the future, we have to refactor our existing code that does the quarterly updates of these IndexCat citations with Fedora 6, and I guess reintegrating that into our workflow and then export it to the actual citation sites. So this involves editing and batch modifications of the F6 objects, as well as the reporting. So yeah, that concludes our presentation of the migration to Fedora 6. Let me know if you have any questions you might have. I'll do my best to answer them. And again, I included the IndexCat website on the bottom that sort of there, if anyone's interested. Thank you.
Thank you so much, Calvin and Lindsay. That's a great presentation. And yeah, as Calvin mentioned, you know, they one of the biggest things I think is coming to that weekly tech meeting and being able to even just talk it out with the team that's there. But I want to leave space for questions, comments. So there is a question in the chat here, Calvin, I can read it. It says, did you say you only migrated the most recent version of a given data stream from Fedora 3? Was that done through the head-only option?
Yeah, so yeah, we only migrate the latest version, but we didn't use the heads-only option. I think in Fedora 3 only stored the latest one there. So that was only once migrated. But you have a history of the version audit trail of each object.
I was wondering if did you do any reindexing on your S3 instance of the application? I'm just kind of curious if there were differences in performance, or sorry, not S3, on your whatever AWS instance of Fedora.
No, we haven't got to that since we were only trying to deploy IndexCat on-prem and not on AWS. So we were only using AWS just for the migration part of it. But I expect it should be faster with the more CPUs cores than on-prem.
I just wanted to thank you, Lindsay and Calvin, both again for the presentation. Definitely a nice look into what you guys are working on and are still working on. So thank you.